have revolutionized the way we perceive and interact with the world around us. The autonomous vehicles to personalized recommendations from medical diagnostics to broad detections and the applications of this cutting-edge technology are truly transformative. As educators and knowledge seekers, it is our responsibility to stay abreast of the latest advancement and equip ourselves with the necessary skills to harness the power of machine learning and data science. Over the next 5 days, we have meticulously curated a program that aims to provide you with a comprehensive understanding of this dynamic field. Through a series of workshops, lectures, hands-on sessions, and collaborative activities, we extend to delve into the fundamental concepts, explore advanced methodologies, and share the practical insights that will empower you to integrate this technology into your teaching and research. This program is not just about acquiring technical knowledge. It is about fostering a spirit of innovation, collaboration, and lifelong learning. The field of machine learning and data science is ever evolving, and it is our collective responsibility to adapt, iterate, and continually push the boundaries of what is possible. By engaging in meaningful discussions, exchanging ideas, and working together, we can inspire one another to create a brighter future driven by decision making and intelligent systems. I encourage you all actively participate and ask questions and engage in fruitful discussions with our esteemed faculty members and experts. They bring with them the wealth of knowledge and experience, and I am confident that their insights will prove invaluable in your journey and discovery and growth. I extend my heartfelt gratitude to all our sponsors, supporters, and partners who have made this event possible. Their belief in the power of education and their commitment to nurturing the talent in the field of machine learning and data science is commendable. Thank you, and I wish you all the productive and inspiring journey ahead. Let the program commence. Thank you, sir.
Thank you so much. Thank you, sir. Thank you so much, sir, for your valuable speech. Thank you, sir. So
Thanks.
before moving to the session forward, I would like to tell that today's first session is going to be presented by Dr. Arpan Gai. I just want to give you a brief introduction about the achievements and all the related information about Dr. Arpan Gai. So Dr. Arpan Gai is a dedicated and accomplished professional in the field of computer science and technology with expertise in computer vision, image processing, and virtual reality. So Dr. Gai academic achievement include PhD in computer science and technology from Indian Institute of Engineering Sciences and Technology, Shipur. His doctoral research focused on automatic developing of camera captured images for alpha slavery text. He also holds an MTech degree in computer science engineering from Kalyani Government Engineering College and a bachelor degree in computer science engineering from University Institute of Technology, Burdwan University. Currently, Dr. Arpan Gai holds the position of Doctoral Fellow at the Schools of Interdisciplinary Research in the Indian Institute of Technology, New Delhi. So in this role, he is engaged in the project focused on line extractions in images and 3D scene extractions, particularly in the context of underwater scenes using virtual reality technology. With over 10 years of professional experience, Dr. Gai has been involved in more than 12 projects, showcasing his versatility and expertise in various domains. Prior to his current position, he has served as an assistant professor at the Department of Computer Science and Engineering in the University of Engineering and Management, Kolkata. Dr. Gai worked as a research fellow at the Department of Computer Science and Technology in Indian Institute of Engineering, Science and Technology, Shipur. His research focused on text line detection, developing techniques and neural networks, and he successfully proposed 5 developing techniques for document images along with various other algorithms and models. Dr. Garai has contributed to the research community through his publication in esteemed journals and conferences. His work has been featured in journals like the Journal of Visual Communication and Image Representation, Neural Computing and Applications, Multimedia Tools and Application, and Pattern Recognition, and several other journals. As a dedicated professional, Dr. Arpan Ghai maintains a membership in prestigious organizations such as IEEE and the Indian Unit of Pattern Recognition and Artificial Intelligence. So this is all about Dr. Ghai. So I would like to welcome Dr. Ghai for this session. Sir, hand, hand over to you, sir.
Yeah, hi. Uh,
Welcome, sir.
yeah, well, yeah. So good afternoon, everybody. Am I
Very good
audible?
afternoon, sir.
Yeah.
Yes,
Okay.
sir.
So first of all, very thanks and feeling honored to be called for this kind of opportunity and also for the giving such a uh, uh, good introduction of myself. So yeah, so it is very good to have such kind of FDPs to be. It is also beneficial for the faculties as well as all the presentees, and also it is a very good platform to actually inter changing some of the ideas of what you are also doing and also I had done or something like that. So it is a very good opportunity for myself. Okay, so actually do not actually just today's presentation.
Yes, sir. Yes, sir. Definitely, sir.
Yeah, okay. My screen is visible.
Yes, sir.
Yeah, okay. Yeah, so there are various domains of this machine learning and artificial intelligence. So actually, we often encounter any kind of text kind of a book or any kind of other types of text can be found. Now, today's world, people have some kind of a cameras and mobile phones with them, and so people often captures from it. And also in your social media, you can often see such kind of images that is present in that. So also in any kind of banking sector or any kind of other government sectors, you will have, face some kind of a document recognition task. So now what is often seen is that there is kind of a distortions present. So in the publicly available OCR or any kind of well-known OCRs like Google Doc OCR and other Tesseract and also others various types of OCR, it is often found that the so we are actually focusing on that first way, that is dewarping of the document image. Uh, so. Uh, so in my PhD, I have actually proposed many techniques such
Sir, your
as
voice is not audible. Yes, sir.
yeah. Uh, is this okay now?
Yes, sir. Yes, sir. Please
Yeah.
continue.
Oh,
Sir, again, we have lost your voice. Sir, there is some issue. Your voice is not audible, sir.
Hello. Am I audible?
Yes, sir. Yes, sir. Please continue, sir.
Okay. Okay. Yeah. So what I was talking is that nowadays people often have some often capture the, document images from the digital cameras that is also available with the mobile phones. So various types of distortions such as warping often generate. So the OCR does not powerful enough to decode that document image or basically work on that image to give some kind of a good result. So we are actually focusing upon to generate some kind of a dwarf document image. So so some for the English script or that alphabetic script. So these are some dewarping techniques are already proposed. But in for the index script such as Bengali, Hindi, and all those things, all those other languages, there is no such kind of a dewarping techniques are proposed, and it has some kind of a different some kind of different features. So these are basically alpha syllabary script. So we are actually focusing upon the alpha syllabary script mainly. So alpha syllabary script are basically top aligned and they are mostly connected with each other. So here we will so that is the main reason that those methods proposed for the English script is not good enough to work with this alpha syllabary script. Yeah, so basically we now we are actually dividing our wait for a minute. Yeah, okay. So basically, three steps of our proposed method is there. So that is, first we actually propose some kind of a warping uh, model. That is the warping surface model. We had given that name. Now that is for how the warping is getting generated. We will discuss in that section. Now we will develop the synthetic document image from that model. Then at the last step we will propose the we will just discuss about the proposed CNN-based dewarping framework. Now that paper actually got accepted in that pattern recognition. So right now, right now I will discuss in these three steps of our approach. Okay, so basically for synthetic, so why we actually proposing this warping model? So basically there are two techniques for actually this warping, synthetic warping generation. Okay, so first of all, why we are actually focused upon this synthetic warping generation? So basically the deep neural network based methods often need the huge images for huge number of images for the training purpose. So basically there are two techniques is there to generate the synthetic images. These are basically proposed by Q and his group and Ma by his group. So none of these techniques actually have kind of a mathematical base for the warping generation. They are basically just bending those lines. So bending the lines is not enough because if you see, if you bend a page, then it will looks like so the characters actually are very much shorter and thinner towards the edge with respect to the characters in the middle. So those types of thing cannot be taken place here, and also some other distortions are there which are not cannot be generated by these techniques, by these two techniques. So we had actually proposed a mathematical model for that, so that it looks like the original images. Now that is okay. So basically we have used this model. So here you can see that we are actually considering this capital MNOP is basically a flatbed surface. Now we here in the C is in the optical center, so of the camera. Here it is the here this is the image plane. So in the image plane, the small MNOP is basically the impression of the flatbed surface. Now we had actually warped this warped surface IJKL. So that if I warp this surface, then we have get this surface in the virtual image plane, that is I small IJKL. Now you can see that, so there will be a distortions like this. So here our aim is to get that amount of distortion due to this warping. So okay, so and also this f is the focal length of the camera. Now yeah, so this is the that is already discussed. Okay, so basically this thing we have to, okay, so for that this is basically the side view of the same model. Here suppose in this there is a point A in that flatbed surface, and there is the due to the warping generation, the point goes to B here. So the point here is the A and the point goes to B here. Now and C is the optical center here. So the angle, so we had actually drawn a perpendicular to the flatbed surface. Here it is now, it is basically the CD is the perpendicular drawn from it. So it is a right angle triangle, and we had also drawn we had extended that to hit that B. So basically BH is basically parallel to that AD. So here it is another triangle. So that angle from this angle BCH is alpha, and this ACB is beta. So now we will so basically from these two triangles we get these formulas. So RS by sine RCS and CS by sine CRS. So basically we get this formula, and ultimately we are getting that AE, we are getting this equation. So AE by sine beta minus alpha equal to DC into cos alpha by sine 90 minus beta. So here again, so here this, if we put those values here, here f is the focal length of the camera and DC is the perpendicular distance. That is, that distance is DC, and f is the focal length, that is so RS is basically RS by AE equal to f by DC. So RS equal to, so that distortion will be f by DC into AE. So here basically this is basically the distortion due to, so basically in our image we get this distortion. So we have to just give some kind of a relation between that environment and this distortion. So RS is the proportional to AE, as the value of f by DC for an image is a constant. Now I calculate the value of AE equal to delta S equal to AF plus FE. Now this AF equal to, we have assumed that this value is gamma plus d tan alpha. So here FE is basically d tan alpha. Now here DCB equal to CFB equal to again alpha, that is alternate triangle from the interior alternate angle. So then BF equal to D. Note that this alpha and beta varies from x and y direction.
extent. So it is basically a matrix. Now D is a 2D matrix. So basically D is basically the depth here. So here A is the flat bed surface and B is the work surface. So basically this is the depth here D. So we will give that D value. The value D depends upon the curviness of the surface, and alpha and gamma depends upon the other external parameters. So here how alpha is calculated. Now we basically this ij is the work surface and mn is the flat bed surface. Now we had placed this camera here, means the camera center is here. So again this same thing. So the now the perpendicular drawn from C to mn. Mn is the flat bed surface and here's the flat bed surface mn and the curved surface at D and F. So in D and F, now let the length of the DAD is A. Length of the AD is A. So that length is considered as A, and in the curve document A, and will appear at point B at the and the straight line distance from F to B. So that distance is basically P. Now we can, if we draw these things, so AE, FH, HB, BE, and FG, such that AE is perpendicular to CF, this AE is perpendicular to CF, that is the CF, and sorry, parallel to CF, and AE and parallel to CF, and FH parallel to AE, FH parallel to AE, and FG. FG is again perpendicular to AE, so AE we had drawn that, and HB is parallel to FG, and BE is parallel to FG. Now BE is parallel to FG, and this angle is considered as theta. Now from that we have actually derived this equation, tan beta minus alpha. So tan beta minus alpha, so we know this formula. So now on that formula we had placed all this AD, all this length. So we from that we had got this, and then we have actually put all those values of BH, FH in that equation, AD, CD, all these things. So we get this equation. Now tan beta minus alpha is that equation. So from that we had got this value of alpha. So we actually know all these things. So DC or else we can also calculate these things. So from that we had actually got this value of alpha. Now similarly we had also calculated the value of gamma. Now the value length of the EB is basically termed as gamma. So EB, that length is basically the gamma, and from this figure it is clear that EB is basically the EH minus BH. So we know the EH is the A, that is the AD, and BH is basically, so if we know this is the straight line distance P. So cos theta, BH is basically P cos theta. So we write this gamma is equal to A minus P cos theta. Now this value of the compute the depth matrix, so that I have already discussed. The depth matrix is the depth. So here depth matrix also depends upon two things. Another one is this that is curviness of the surface and the camera angle. Now the depth of the perpendicular distance from the curved surface to the flat bed surface, and it depends upon the curviness of the surface and the angle between the T and the flat bed surface, that is basically the camera angle.
Adding a file now దాంట్లో ఉంటది కదా.
Any questions are you asking? Okay, so where T is basically a tangent drawn from the point where the flat bed surface is So here we had actually drawn this surface. So actually here, suppose the camera is held in that angle. So due to this angle, some depth is also added. So we are actually calculating that depth, and this and also this rho. So rho is basically that depth. So total depth is that depth and also plus that depth. Now from that ultimately we are getting that. So here from that we are actually getting this rho xy. Rho xy is basically the depth due to the curviness. So the curviness is dependent upon the environment, and this and camera angle is b into tan phi. So b is that length, that is vf, and tan phi, phi is that camera angle. Now, so to generate the synthetic images, we had actually shown that in the mathematical model that is in that alpha, gamma, and d are the basically those parameters that we need to give. So alpha is basically the if we actually place in the basically camera position due to the camera position, and gamma we had to have is that means those parameters, and d is the depth. So alpha is again dependent upon these things, beta, a, dc, and p, and theta. So gamma is also dependent upon all these things, and d is dependent upon these things. So ultimately, if we give these parameters, the value of these parameters, we can generate the what. So basically, here what we are actually doing to generate the synthetic images is that we are actually taking a flatbed surface image. So basically, if we scan a document, then we can have that flatbed surface image. Now, if we give these values of this DC, CP camera angle and this depth for each position, so then we can generate some kind of a warping factor, and based on those warping factor we can actually generate some kind of a warping. Here we are actually measure the perpendicular distance from the for giving the DC. We are actually measure the perpendicular distance from the flatbed surface to the length of the camera while capturing that to the flatbed image, and then focal length is also known for the camera. So this is basically dz plus f. So dz is basically the distance from the flatbed surface, and for the camera position, it is basically we are basically specifying a kind of coordinate CP. So from that and that actually we are giving in a normalized version, that is that actually follows between 0 and 1. Then we are actually multiplying that with that row and column size, so basically size of the image. So then we are actually getting that CP as the camera position, and the camera angle we are actually giving some kind of a, we are in some x direction there is a angle, there will be angle, and for y direction there will be another angle. Now these are actually phi r and phi c we are giving, and positive and negative values can also be there. So we are actually putting all those things, and similarly we are actually giving the depth, so rho, and the camera angle is the other thing. So rho we are so for the rho we are actually giving two types of parameters. One is position parameter and another is the control parameter. Position parameter is basically where the warping is less is defined, and all the other things basically, let me. Wow. So here, how is actually giving the position parameter? So here, this line of the jet. So at the top, where we there here along this Z1, Z2, the warping parameter value will be less, and towards the edge, the warping factor will be more. So here we are actually specifying this Z1, Z2 by camera position parameter, and at the middle of this Z1 and the left side there will be another line will be there, and then similarly to at the left side also there will be another line. So there, and for the camera control parameter we will give some values there in that position. So basically three will major parameters, control parameters will be given. So at the middle, so basically at this Z1 point the camera warping will be 0. At the x1 it is taken as the I think 1/3 of the of this value here. So basically using camera control parameters we are giving the depth, and the warping position parameter we are actually giving the where is the minimum and where is the maximum. So if we move that Z1 Z2 here, so in that case the warping will be towards the right, like that. Yeah, so here how we are actually here, so after giving all those parameters to distribute that we actually use this formula. So it is for the fourth node, basically we are actually using the cubic smoothing spline. So for each of the row we are actually following the cubic smoothing spline to give the camera to spread the control parameter, so that we give a smooth image. So here it is basically the camera control parameters are here. So one example is shown here. So it is the first node here. So here you can see that camera position, it is the 0 position, and here it is given like that. So camera position. So here it is at the left end, and it is at the right end. So here you can see that the camera control parameters, value of the control parameters are maximum here, and we are actually giving using cubic smoothing spline. So how we got these types of warping? So here ultimately these warping factors are given for the entire image. Now here you can show some kind of example. So this is the input image that we are actually giving. Now as we actually apply that warping parameters here, so here position parameters are towards the left side of the image, so it is warping like that. And now if we place that camera position parameters towards the right, then we get these types of images, and it is for the middle. So here you can see that suppose an image is pasted on a lamp post, so then these types of images, there is a figure D, these types of images we can find, and for the book you can find these types of images. Now here actually we are actually analyzing how good is our method. So here we have actually taken one original image. Now we have actually binarized it. Now it is the B is the original image in a binarized form. Now here we have taken the same page at that, and then again we have working with our working parameter. Now you can see that these characters towards the edges are little bit shorter towards the in the original image, and at the middle
What is this?
yeah, okay. And so for similarly for our images also, our generated images also, here the camera our characters are shorter and thinner too with respect to the character towards the middle. So you can see that these types of distortions we have able to generate. Now we are actually feeding to that CNN based framework for dewarping. Now here actually what we are doing, we are actually here we are actually giving these so here the values of the parameters, camera angle, camera position, depth of the surface. All these things are estimated using the CNN. So here for generating the warping, we have actually given these types of these values, the camera angle, camera position, and the depth of the surface. Now we are actually giving the CNN-based framework a pure image that is in a 2D image in a real world image. Now from the real world image, if we actually try to calculate those parameters. Now for synthetic image generation, one positive point is that we have all those things, all those known things, because we have actually given those values to generate that, so that actually we know those things. So ground truth is already known to us, and for the synthetic images we can generate as many images it is possible, but if we want to generate this real world image manually, it is a very tedious task to do. So we are actually generating the images synthetically, then we try to train the CNN model to get some kind of a dewarping factors. Then we will get this dewarping, and then ultimately we will, from those dewarping factors, we will get for these parameters we will get some kind of a warping factors. Then from those warping factors we will create a dewarping factors from that. Then from those dewarping factors we will generate the image. Actually we will generate the dewarped image. Now, two subnetworks are actually used to calculate the. Okay, so actually, our CNN model have 5 subnetworks. So in that 5 subnetworks, 2 subnetworks are used to calculate the camera angle and the camera position, and then the depth is estimated from using that PP and CP. So here the position parameter and the control parameter. Now we will have some kind of a dedicated network, dedicated network to generate the camera position parameter and the camera control parameters using our CNN based subnetworks. And find the position parameters, and 2 subnetworks are used to find the control parameters, and we have used these synthetic warped images during the training and the validation. Next, the training network is based on both synthetic and the real captured images. Now this is basically the flowchart of our technique. So here we are actually giving this input image here. Now after pre-processing, during the pre-processing, we are actually discarding those boundary noises, and we are also binarizing it. Then we are actually Q angle detection. So we are actually applying some kind of a already given proposed the skew angle. Now we are actually deskewing the image. Then we are doing this line segmentation. So for the line segmentation also, we are actually adopted some kind of existing techniques. Now basically all those, after segmenting the line, we are manually blurring, or maybe kind of a automatic way to blur those images, dilate those images. After dilation, we will prepare this for the network. So to prepare this for the network, we are actually rescaling that image and fit it into a 150 window, and then we are feeding to that network to get those values. And for the training also, we had followed the similar approach. After warping those images, then So similarly, we are giving to all the 5 subnetworks here. So here subnetwork 1 is basically position parameters P1 and P2. Subnetwork 2 is for the P3 and P7. This is basically the control points of at the top. So here using this P3 and P7, we can give the reworking factors at the top the first row of the image, you can say. And the subnetwork 3 is basically for P6 and P10. So P10 is basically, or this P6 and P10 is responsible for giving the working factors at the bottommost row. So ultimately from these we are actually calculating the depth. Now for subnetwork 4 also we are actually giving these types of images. Now these images, from these images we are actually getting the camera angle using this subnetwork, and for camera position also we are actually using this subnetwork. Now ultimately we get these values. Then ultimately we are actually creating these working factors, and from that working factor we are actually creating the deworking factor. Then we are we are actually after Q correction of the image, we are actually applying these reworking factors to the image. Then we are getting the deworked image. That is the flowchart of our approach. So for the pre-processing, so first this binarization is done, and the denoising of the document image is also done. So for both of, and adaptive binarization we have used, because as you know that some kind of lighting and the shadows, so a single global binarization is not a very useful one. So we are actually performing this adaptive binarization. So actually it is given by this two et al. Then we are applying those, we are actually adopting this method, and also for border noises and also other noises, we are actually applying this method proposed by Bukhari. This is especially generated for the camera captured images. So we are actually adopting that, and for the non-text part of the document image, we are actually removing if there is kind of a figure is present in the document image, or any kind of other types of stuff like table and all these things. We are actually not considering those part of the image. So we are by kind of connected component analysis, we are removing those things. Then for during training also we have removed, and for testing also we are removing that. But actually, so ultimately we are able to get those parameters using those. Now for the skew correction, so as you know that for the camera captured images, if we held the camera a little bit in an angle or any kind of so various hues can be various amount of hue often get there. So if the hue is present, so it is very difficult for our network to get the parameters, values of the parameters. So we are actually dehueing the images first. So a projection profile based methods are performed well for the images having flat bed surface, but the projection profile based method does not work for the warped surface, because at the top there is some kind of a warping. So that often, so there is kind of a, due to the warping, there is kind of other angles are often there. So those projection profile based methods fail, because some other, if as the other angles are also present, so it is often added with the skew angle, so wrong angles is given. So to calculate the skew angle, we consider the text image having the length greater than 0.8 into HM. HM is the longest text line. So using that, we consider the bottommost point of the leftmost and the rightmost character of each text image. So basically we are considering each of the lines. So from that line we are actually here using that we are getting that if the line is significantly long or not. If it is significantly long, then we are taking those bottommost point of the leftmost character and the rightmost character. Then we are getting some kind of a angle. So and we are ultimately we collect all those lines in the text, and then mm, we are actually trying to get kind of a angle, Q angle. Now from that two points, we are actually getting a straight line, and then we are actually trying to find the angle between the horizontal axis and that line. Basically, here it is explained. So here we are actually taking all those long lines. Then we are actually taking the bottommost point of the first character and the bottommost point at the last character. Then we are actually joining those lines, and then it is the angle S1 here is the angle with the horizontal axis. Similarly, for these 2 points, this is the angle with the horizontal axis. So S1, S2 for these two lines. Similarly, we get angles for all those lines. So here, if we take the average of that line, so here we can find the Q angle. So here we had actually taken like that. So we have calculated the Q angle like that. So this is a skew corrected image. So here it is a skewed image, and this is the de-skewed image. Now the text line segmentation. Here we use the technique proposed by Liu that is capable enough to segment the text line in a camera capture document images having curved surface. So for the flat bed surface images, some projection profile based method is already there to segment the text line. So but for the warp images, those types of methods often fail. So we actually take these Liu-based method that is actually proposed specially for the curved surface images. This method actually first calculate the minimum bounding rectangle of the connected component. So it is, and then a minimum spanning tree is drawn using both those minimum bounding rectangles generated, and then the text lines are segmented using the generated minimum spanning tree. So it is again a non-neural network based method, but it actually these graph based techniques often also gives good results for these types of images. The text line segmentation methods undergoes a morphological closing operation using the line-like structuring element such that each connected component represents a text line. So here this is an example. So what we have actually done here for each connected component we are actually getting a box. For suppose this first word we are getting a box, second one we are getting a box, and so on. And for these all the lines we are getting a box. So here if we generate a tree using that, so then there will be a connection with this. But if we kind of put some threshold only upon this axis, then we can segment these lines. So only these connections will be there. So that is basically the Liu method. So using the minimum spanning tree. So here for each branch of the tree will be a kind of a line. So here, and then ultimately after getting the line, we are dilating these images. So here you can see that each line is basically a connected component here. So because as we are not focused upon the characters, only we are focusing upon the orientation of the line. That is why we had actually put these types of method. And also another reason is that if we in the next step we will decrease the size because we had a kind of limitation for the hardware for the GPU and all. So we are actually trying to propose some approach so that we does not have to wait for the bigger GPUs. But on that time when it is proposed, so in on that time we are actually facing kind of a problem with the limitation of the GPU. So that is why we had actually taken that approach. Basically, we had actually dilating the morphological closing operation of those lines, and if we decrease the size of that, then also this orientation does not affect, and also the characters does not get removed. So if we actually we are actually when we actually proposing that, we had actually directly trying to resize that image into 150 cross 150 or something like that. So then we are actually facing like these characters are often get removed because this stroke width is sometimes very small. So characters got removed. So if the characters got removed, then the amount of then the neural network is often failing for giving some kind of a right value for the working parameters. So here we had actually dilated that to remove that problem. Now we are again preparing for the network. So that is the next step for the neural network to be prepared. The size of the input image is 150 cross 150. But if we directly rescale to that size, then the shape of the images will be again distorted. But we don't need to we cannot allow the image to be distorted like that. That is why what we have actually done, we had actually scaled down by keeping this height width ratio almost same. So we are actually so this equation is followed while we are actually scaling down these images. Now here small h and w is basically the height and width of the small image, and the capital H and W is basically the line segmented image. That is a morphological closed image. And then after resizing it, we are placing that 150 cross 150. We are actually taking an image and blank image of 150 cross 150. Then we are placing that scaled image at the middle, and then we are giving that we are giving that image to the network. So here it is an example. Here you have this is the line segmented morphologically closed image. Then we are rescaling it, and then we are placing it into the 150 cross 150 window. Now, as I have already stated that our network is basically contains 5 subnetworks. Each of the subnetwork is a modified version of BGG60 network. The detailed description of the subgraph is given in the table. Here you can see that subnetwork 1 having 17 weighted layers, subnetwork 2 and 3 are having 25 weighted layers, subnetwork 4 is having 19 weighted layers, and also subnetwork 5 having 19 weighted layers. So these numbers actually are kind of a experimental results. Means we are actually done some kind of a experiment to get this correct value. We are actually trying to interchanging some kind of a, we are actually trying to add convolution layer at the first or maybe at the last, something like that. But we are getting the best result using that using that settings. So here you can see the input size is 150 per 150. Then after giving some convolution layer, we are actually applying some max pooling. Then even after some convolution layer, we are actually giving again some expooling and so on. So ultimately, we are having a fully connected layer at the last. Then at the last, we are getting the regression layer. That is for each of the networks. We have that. Now, here each convolution layer is followed a ReLU and a batch normalization layer, and we have used that SGDM optimizer, standard gradient descent with momentum optimizer, to reduce the number of parameters. We have used only one fully connected layer, followed by the regression layer. So as we have already stated that we are actually using the synthetic images for training. So here we are actually applying more than 10,000 synthetic images during training, and actually among that we are 75% are used for training and 20% is used for validation. Remaining also we had tested, and we had also tested for the original images. But for the original images, we do not have those values. Okay, so next, we depending upon the application, the number of features of the convolution layer and the size of the convolution window, size, and the size of the window at the multiplying layer are more modified. So here we are actually, so this subnetwork 1 is for this P1, P2, this position parameter. So here we had actually faced like it is as it is in the left side or right side, or what is the amount of that. So here so that P1, P2 is responsible for that. So for that we are actually having these 17 weighted layers, and subnetwork 2 and 3 is basically calculating the depth of the at the corners. So that actually depends upon these distances from the top side and at that side also, and from the bottom also. That is for P6 and P10 for that side and that side. So left side and the right side, what is the amount of depth here. So for subnetwork 3, we are actually also having 25 weighted layers, and camera angle and camera position. For that we are having 19 weighted layers, is 4 and 5. So that is how we are getting this results. Now subnetwork is one is used to find the position parameters. Now for the position parameters, here we have actually taken assume that the P1 and P2 value of P1 P2 are same, and for the control parameters also we are actually assuming here that P3 and P7 is same, P6 and P10 are also same. So subnetwork 2 and 3. So if anybody wants to extend that paper, then he or she can just do not consider these things are same, and we can also always open to extend our work. And subnetwork 4 is used for determining the camera angle, and subnetwork 5 is used for predicting of the camera position. Now, after getting, so if we know those things, know those parameters, as during training, we are actually directly giving the working parameters. So here also we are actually basically getting the warping parameters, not the dewarping parameters. So basically, what is the reason of the distortions we know right now. So, but how to resolve that? That is we are going to discuss in this slide. So basically, what if we know the reason, then from that reason, if we resolve that, then we can get kind of a amount of distortion. So the values of this CP, phi, and rho, they are estimated using the CNN. Now, most of the document images captured from the distance of 35 to 50 centimeters, that we have also assumed that. So that is also another assumption. So here we have actually given that height directly, and we have also chosen this distance DC to be 1.5 into IH. So IH is the height of the image. So this is also given. So now from these values alpha, gamma and D are calculated. Next this delta I is calculated using this value. So delta I is basically the warping factors. Now now we need to translate that to dewarping factor. Now using that formula we are actually getting the inverse warping factors or maybe the dewarping factors. So here we have stated that as inverse warping factors. So basically here we have used that formula to get the dewarping factors or the inverse warping factors. Now, now it is the time for the images, that is the output of our proposed method. So here, so as we had also at the beginning, we had stated that we are mainly focusing upon the index script, but we had also tested our method to in the English. Sorry, we had actually proposed for alpha syllabary script, that is not for index script like Bangla, Devnagari, Punjabi, Gurumukhi, and Assamese, and all these languages, and also for South Indian languages also it will work. But for the but for the testing also we had also tested first the English. So for English, many people has done the dewarping like for DFK dataset. Now this DFK dataset is a very popular dataset for English script. Now we had tested on that, so we are getting these types of output. Here you can see that these are the already proposed method like CTM and CTM2, SCG and SKEL and couple snakes and methods by Meng. So here the last it is the proposed method, output of the proposed method. You can see that the output of the proposed method is quite good enough, and also it is all maybe it is either similar to the existing works or it is better than that. So here for D and E it is our works are better. And another data set for English script, that is doc3d, that is quite a recent one. Now some proposed method by Kim and Ma, we are getting these types of output. So here you can see that it is not too good actually, but here for our proposed method it is giving quite good results. Now ultimately it is for our data set. Now our data set WDID has 258 images and also the corresponding ground truth. So our data set also have kind of a line segmented images and some border noise removed images. So if anybody are working on these things, so they can use our data set. Our data set is also publicly available. So and also if somebody is facing any problem to finding that data set, they can always open for mailing me or contacting me to get the data set. And so this is the WDID data set. Now here and this is the first image, the input image. Now the next image is given by the output of the Kim method, and another this one is given by this Meng and all, and then his group. So and last one is our proposed method. So here you can see that their methods failed actually due to the feature of the Bengali script, and these methods are claimed in their paper is that their method is basically script independent, but here uh, in case of our dataset, it is seen that their method failed due to in the Bangla script. But for key method, it is giving quite comparative result. But here you can see that our method gives the best performance. This is all from our my side. Any questions?
So, thank you, sir. We are having a
Yeah.
wonderful session. Thank you, sir, for all your efforts and all the information that you have given today. It's quite valuable and it's one of the unique thing that we have learned today. So, we'll ask to the participants if they are having any questions, please either to ask the sir directly or you can post it in the chat box. So, sir, I think we are having one question in the chat box also.
Yeah.
First is, sir, is there any hands-on or showing the extension of CNN by Mr. Vinod Babu?
Mm, and so actually here we for our method we had actually used MATLAB, and also currently we are actually doing in Python, but in that paper actually applied in MATLAB. So the codes are also available with that paper. So it is paper link is given at the very first. Okay. Yeah, so this is the paper. If somebody wants to kind of get the code and try to practice, or maybe how the code is written, so that thing is available with the paper. So anybody can, so it is in the GitHub, I think. So the GitHub link is there, and also how to use that code. It is also written on that paper, and also written in that README also. So anybody can read that and also try to get the hands on. If any problem occurs, then I am always there to help. Anybody can contact me in my mail, and yeah.
Yeah, sir, it's a wonderful work, sir, that you have put everything on the online. So all the participants, sir, just have shared his own paper along with the code also available on the internet, which is also available to everybody. So
Yeah.
some of the
Also, the dataset is also available. If somebody wants to do more research or using our dataset, they can also have that. It is the link is also given in that
sure, sir,
paper.
it would be quite
And
helpful for all our participants. Yes, sir.
yes, and also some any kind of assistance to PhD or something like that, I am also available. And and also in my website also there is the mail IDs, and also all these things are available. And yeah, so yeah, please go ahead.
Sir, next question is there any techniques to generate the synthesized images by Pranita?
Yeah, the
Paranita,
synthetic. Yeah, I had got that question. Yeah. So basically, for synthetic image generation also, that is also done in MATLAB. So these codes are also available in that paper. It is not using the GPU, so anybody can generate the synthetic images. It only takes the CPU, and also it takes a little bit time for generating maybe more than 10,000 images. But if anybody can run on that CPU, it is already codes are already given. So synthetic image generation can be possible by anybody. Any
yes,
is
sir.
that the question satisfying? Means is that okay? Or anything else you need to know?
Actually, sir, Paranita is asking for any other tools to generate for these synthetic images. Is there any
Actually,
specific?
there are tools is there. Means one in a paper that we on that time we I had searched with just a minute on that wait no, here it is not. Yeah, so here you can see these in these two papers. If anybody can search, then there are two. Basically, it is a scanner itself. By Q, that method, the scanner itself can generate the warped image. But in that they have in that method by Ma, what they have done actually, they have actually generated a mesh, and then using that mesh they are actually just shifting the pixels. but tools they have not make it publicly available, and also I don't know if any tools has available right now, but on that time it was unavailable. I had done one extensive search, but on that time that synthetic image generation tool was not available. On maybe 21 or so, but I don't know about the most recent time. But and also, but if anybody, so if we have any MATLAB, so you have to just install MATLAB and we can run my codes on that, so that you can directly easily get the images generated. So yeah, that is
Thank you, sir.
the thing I can say. Yeah.
Yes, sir. Thank you. Any other participants has any other questions? Please share. So I think, yeah, sir, Vinod Babu has, thank you for such a wonderful session for all these CNN details. Yeah, sir, actually the participants required to share your contact details. So we will also share the PPTs as well in the after this session. So thank you, sir. Thank you so much for this
Yeah.
wonderful session. This is
Thank you.
quite a unique of its own. So I think our participants have already enjoyed this session very good and gained much from this session. Thank you, sir. And hopefully we will, our participants will also, if somehow feels some problem, they will definitely contact you over there. So we would like to thank you, sir, again, once again, for all this wonderful session. Thank you, sir.
Yeah, yeah. Also, I am very much happy to be here to be presented in front of such enthusiast participants, and also quite honored to be here to that BBRIT. So, yeah, hope for the best all the participants and also from the other, yeah, other ones, and best of luck for this institute. Okay, and thank you. And
Thank you, sir.
always my yeah, always my email ID is there, and also my contact details are also there.
Yes, sir.
Anytime, anywhere, you can again contact me or any kind of assistance.
Okay.
Okay,
Thank you,
thank you.
Arpan sir, for your valuable time.
Yeah, thank you.
Thank you.
Yeah, yeah. Hi.
So for the all the participants, so we are having our next session, which could be given by Mr. Vishal Kumar Jaiswal. So I would like all of you to be there for our next session. So our next session, which could be quite interesting, which is on IoT security for product designing, which is given by going to be uh, introduced, I think, by Mr. Vishal Kumar Jaiswal. So just let me introduce. Mr. Vishal Kumar Jaiswal is an accomplished professional with extensive experience in the field of testing and certifications. With over 5 years of dedicated work at STQCT IT services, he has demonstrated remarkable expertise and made significant contributions to various projects. So, Mr. Vishal's career highlight includes his involvement in several critical initiatives such as Aadhaar, L0, L1 registered device certification, third-party compliance audits of AUA and KUA, and drafting BIS standards for IoT security and privacy draft standards. His comprehensive knowledge and meticulous approach has ensured the successful execution of these projects, contributing to the enhancement of the security and compliance standards in the country. In addition to his project work, Vishal has excelled in various other areas. His expertise extends to the web application security testing, GIGW website certification, e-procurement, system certification, API testing, audits, and so on. Through his diligent efforts, he has helped organizations identifying vulnerabilities, strengthen their security measures, and optimize their testing processes. His exceptional skills have been invaluable in ensuring the reliability and efficiency of IT systems and applications. So Mr. Vishal holds a master degree in computer science and engineering from IIEST Shipper. His educational background combined with his practical experiences has equipped him with a solid foundation in the field. Prior to his tenure at STQC IT Services, he gained industrial exposure during his brief stint at Uttar Pradesh Power Grid Corporation Limited, where he further honed his skills. As a speaker, Mr. Vishal brings a wealth of knowledge and insight accumulated over the years. He is adept at sharing his experience, discussing industry's best practices, and providing valuable guidance on IT services, certification, and security. So I would like to welcome Mr. Vishal Kumar Jaiswal to for the next session. So welcome, sir.
Vishal Kumar Jaiswal, Scientist C from STQC IT Services, Bangalore. Can you give me sharing permission?
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
just
Sir, please try.
Sir, can you
yeah.
please
I am
switch on your
not able
camera,
to
sir?
share my screen. Please provide
Mr.
Sir,
permission.
Vishal Kumar, just one, sir, please switch on your camera, sir.
so
Yeah,
you can switch on the
I am
camera,
not
sir.
able to share my screen. I don't have presentation permission, I think.
Okay, 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 sir. Wait a minute, sir. Wait a minute, sir. Yes, sir. We have assigned the permissions.
Yes. Yes. Are you able to see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
So
So
would like to
let me introduce
welcome you,
myself.
sir.
Yes. So let me introduce myself. I am Vishal Kumar Jaswal. I work as Scientist C with ETDC Bangalore. It is under STQC Directorate, which is an attached office of Ministry of Electronics and Information Technology. So we are primarily in the domain of security testing, functionality testing, performance testing, and we provide some certifications as well. One of the critical certification we provide is e-procurement certification. So in that, as per Central Vigilance Commission, any e-procurement system which is to be used in public procurement system, like from government departments or involving some other organizations, so that has to be certified by STQC, as well as IoT cameras for railways. So any IoT camera or IP camera which is to be used by railways, that has to be certified by STQC, and some other IoT devices like uh, one of the example is what certification scheme is running is for Aadhaar. Aadhaar registered devices technical specification is there. As per that Aadhaar registered devices technical specification, we certify biometric devices for fingerprint as well as iris. So that has two levels, L0 and L1, and we are certifying. We have already certified approx 200 devices for L0, and for L1 4 to 5 devices we have certified. So any biometric device which connects to Aadhaar ecosystem, that has to be certified by us. So on similar lines, government is having IoT certification scheme for various IoT devices, and we are involved into drafting of several international as well as national standard for IoT ecosystem security and IoT devices. So I will go through brief introduction of IoT security, and then I will move to what we use practically. Yeah. So IoT refers to network of interconnected physical devices that communicate and exchange data. So basically, any device if we will connect to internet, and it is exchanging data with internet, and it can be controlled, means sensing and actuation function can be performed using internet. That becomes IoT devices. But it has a lot of risk because it is a cyber physical system. It can pose safety risk as well. So because of that, it is of concern that IoT security and privacy should be taken care of. So in this presentation, I will cover security and what mechanisms or measures can be put into place for IoT ecosystem security. So what are the challenges? One of the primary challenges, lack of standardized security protocols and frameworks for IoT devices. So basically for till 2022, there was no standard in the domain of IoT security, and the protocols which are being used or which are being deployed by industry, that is also not certified protocol, as well as like people customize it. Okay, so because of that, a lot of insecure devices were being introduced into IT or IoT ecosystem, and that was creating a threat surface that was very difficult for organizations to manage. So second thing is vulnerability in IoT devices or software, that is very difficult to address because many devices are in field, and how to provide software update to devices for any security vulnerability, that is a question. Inadequate authentication and authorization mechanism, because these devices are unattended in nature, so how to provide proper authentication and authorization mechanism so that only correct user can access that particular device. Next is privacy concerns, since IoT devices are involved into very intricate tasks of organizations, like camera can involve into very different scenarios by defense in ministry or other organizations. So privacy concerns are also very much relevant to IoT devices. Next is distributed denial of service attacks leveraging IoT botnet. So suppose some consumer IoT devices are there, and that devices can be made botnet, and that can be used for attacking critical infrastructure. So how to address these challenges? So what are the typical security measures? Security measures are many, but some of the top security measures I am going to highlight. So one is strong authentication and access control mechanism. Next is encryption of data in transit and at rest. At rest, it is most important because IoT devices are unattended, and somebody can do reverse engineering or IoT forensics to try to extract the data from the IoT device. Next, regular security updates and patches for IoT devices. So somebody has to take care of IoT devices patching. If there is any zero-day vulnerability found into IoT devices, then it has to be patched radially. And any vulnerability is there, then all the stakeholders should be communicated with that particular vulnerability information. Next, implementation of only secure communication protocol and removing the legacy protocols, because a lot of protocols with time they start degrading in security. So that protocol needs to be phased out, so that only secure protocol like TLS 1.3 or secure MQTT can be put into place. Network segmentation, it is difficult to implement in outside environment, but it should be implemented if IoT devices are within your IT system, so that IoT device related threat surface can be limited to that particular network segment, and it is not affecting your regular IT environment, because that is one of the entry point. IoT devices are one of the entry points into your organization's IT systems, and that can be easily compromised. Monitoring and anomaly detection to identify potential threats. So these are the variety of devices. So we are involved into standardization of IoT security, and you can see how to write standards for these categories of devices. It is very difficult to achieve. So we are trying to cater to that requirement. So one of the case studies is like a smart home device such as smart locks and security cameras. So that are also susceptible to breaches, even exploitation, extortion, a lot of things are ongoing. So one recommended thing is like you should use a strong password or two-factor authentication for your smart home devices. Otherwise, somebody can perform extortion also, like social engineering attack for that IoT device. Next, regular firmware updates you have to do, and if you have to perform a regular firmware update for all these categories of devices, it is going to be very difficult. Next, network segmentation. Try to segment that IoT or smart home device from your network so that it is not affecting other critical devices or servers. Next, encryption of data exchange between smart home devices and the cloud. You should try to purchase not only cheap devices but certified or secure device as well. So what are the types of testing of IoT secure IoT devices? So one is black box testing. So I will discuss here some of the black box testing. One is like penetration testing. So this is like simulating real world attacks to evaluate the resilience of IoT devices and system. This can be performed using automated tools or some red teaming frameworks. And vulnerability assessment, identifying and categorizing potential vulnerabilities in IoT systems. Next, one of the critical steps which we look at is a security code review, since code can contain some test features or code can contain some backdoors also. So how to address that particular backdoor related requirement? We have to perform manual code review as well as tool based secure code review. So that code review is performed in line with some international standard like CERT-C standard is there for C, or MISRA standard is for automotive security. Some military defense related standards are there for C programming language, as well as for Java different standards are available. So since in IoT devices mostly C language is used, that's why this secure code review mostly follows OWASP CWE or CERT-C standard. Next is wireless network testing. So we test using some standardized tools that wireless network which is being used, that is secure enough or not for withstanding the attacks. One final requirement is like evaluating the physical security control and tamper resistance. Since IoT device is not into your domain, or it may remain unattended and outside your home or organization, and it can pose, since it is connected to your network, it can pose cyber security attacks on your particular ecosystem. So the physical security is very much necessary. Simple example, some of the devices like UID ecosystem, Aadhaar ecosystem, they have tamper resistance implemented in L1 category. So if you try to open, so they will delete all the firmware and everything from the device. So now I will tell steps of IoT device security. One is, first we have to define the target of evaluation. So we have to define scope, objectives, and target. Target of evaluation means what is the IoT device, what are the security requirements for IoT device, and whether the vendor or the product manufacturer has implemented that requirement within IoT device or not. Second is the environment, like suppose we are certifying IoT devices for a defense grade security establishment, so in that environment how IoT devices can be attacked. Okay, so based on context, IoT we have to plan our security testing. Next, we have to gather information. So we have to collect information about IoT device, network architecture, and communication protocol through multiple mechanisms on internet, as well as like FCC ID will give you information related to its complete enclosure, what is there like SoC or microcontroller or microprocessor within it. So we have to gather the information, then we have to perform vulnerability scanning using well-known tools like Nessus and all for IoT devices systems or protocols. Next, since a lot of exploitations are already available on internet like exploit.db or Google Docs, so we can try to exploit that particular vulnerabilities. Next, we have to report that vulnerability so that a particular vendor can remediate that vulnerabilities in the IoT device or its ecosystem. So what are challenges in IoT device security testing? One is heterogeneity. Suppose we have to purchase tools, okay, for IoT devices as a government entity. So it is very difficult to procure that type of tools, because a lot of different microcontroller or microprocessors are in place and that are embedded in nature. So for each device, different set of tools are required or softwares are required for performing code review to performing automated scans or attacks. Next is scalability. Large scale IoT deployments present challenges in testing and securing all devices. So we are a small organization, but for testing IoT devices, we need a very huge number of labs so that they can perform for each category of IoT devices or each IoT device some sort of testing. So scalability is an issue. Limited resources, IoT devices often have constant computational power and memory. So testing it IoT devices so that within that constant power and memory, it can perform the cryptographic operation, it can perform the secure boot, it can perform the secure update, as well as support the tamper resistance. It is very crucial that this limited resources clause is taken care while testing for security. Next is legacy system. So many of the smart cities, they have retrofitted a lot of IoT devices. So retrofitting IoT devices into modern IT systems or as per principles of is not as good, and it can create problems in future, very near future. And one of the thing is testing IoT devices may involve sensitive data, and it can have privacy implications, since if any leak of information happens, that is a problem. So next I will cover artificial intelligence uses in IoT security. So AI, as in other fields, it can play a good role in IoT security, and we can solve some of the challenges in IoT security using AI. So one is machine learning can detect anomalies and identify potential threats. Deep learning models can analyze vast amounts of data from IoT devices for identifying patterns and vulnerabilities. And AI-based intrusion detection systems can provide real-time threat detection and prevention. So one example is earlier UIDI was matching based on some algorithms for fingerprint as well as iris. Now they are employing this machine learning and artificial intelligence based techniques so that fingerprint can be detected whether it is spoofed or not. Liveness detection, for that purpose UIDI is employing a lot of machine learning techniques. So AI powered anomaly detection, anomalies in IoT device behavior can indicate potential security breach. So AI algorithms can be used for learning the normal behavior of the device, like signature detection, and based on that it can identify some deviation. So if unusual traffic pattern is arising, abnormal sensor readings are happening, or unauthorized access attempts are there, so in that case using AI we can detect it, and it can help into providing threat detection and mitigation. So what are the suitable standards? So for suitable standards, you can refer to 20924. This is IoT vocabulary standard. Here definitions related to IoT is available from ISO IC, and you can refer to IoT reference architecture. This reference architecture provides a base or foundation for IoT ecosystems throughout the world. It is published in 2018. Next is 27400. This standard provide ecosystem related IoT security and privacy guidelines. Next is 27402. This standard provide cyber security related requirements for IoT devices which are baseline in nature. Simple example, IoT devices should have unique identity so that it can be identified inside the network except IP address. Okay, many of the IoT devices don't have unique identity itself. So this particular standard provides a requirement related to these baseline requirements. And 27402 403, this provides IoT domotics related security and privacy guidelines, as well as NIST had published a lot of standards or publications or special publications related to IoT devices. So first I will cover some industry tools. My screen is visible now.
Yes, sir. Yes, sir. Please continue.
Yeah. So since IoT devices are at this level, as per 30141, these IoT devices tends to monitor the physical environment. Physical environment can be monitored using simple example is in Big Bazaar. You can go and using tag they monitor whether the particular cloth or particular item is being taken out, or fast tag is used for movement of for tracking the movement of vehicles. Okay, so IoT devices generally perform the sensing task as well as actuation task. So it senses some data from the physical entities domain using with the help of tags, okay, and perform some actuation function. So these IoT devices, since these are very small in nature, they connect to IoT gateway, or sometimes they have the capability of IoT gateway. So they connect with Zigbee, LoRa, 6LoWPAN, or some other proximity network technologies to nearby IoT gateway like Bluetooth energy. So using Bluetooth low energy, these IoT devices will connect to IoT gateway, and some sort of capabilities for edge computing will be present with IoT gateway. And this IoT gateway using 5G, Ethernet or 4G technologies, they connect to cloud or server. So these cloud or servers will have billing management, subscriber management, mobile app exposing to outside users. So basically IoT devices will be controlled using web interface or mobile interface, voice assistant and all using this cloud. So this ecosystem we need to secure. So for this 30141 has provided reference architecture. This is very foundation of IoT ecosystem. It is going to be revised very soon. So I am showing the draft of it in fast forward mode. So based on this ISO IEC 30141 reference architecture and 27400, which is IoT security and privacy guideline document for complete ecosystem, we wrote a BIS standard for this IoT security. It is under draft stage, so it is going to be published soon. So we have published this 3-part draft standard for this one. I was involved primarily in this one. And some tools I want to provide for this workshop. One is Postman tool. This tool is very much useful for testing APIs. Since IoT devices talk with outside environment like mobile app or server using APIs like Open API based specification. So you can use Postman tool. It has a runner concept. Using that we can perform testing of IoT ecosystem or IoT specific APIs and see whether APIs are vulnerable or not vulnerable. Okay, so this tool is very much useful into IoT ecosystem, and this provides very good report in the form of this report. Newman one tool is there which provides HTML reports for Postman related tests. So all this we can test it. Next is Wireshark tool. Using this, whatever communication is happening on USB or Wi-Fi network, we can see its traffic and try to gather some information or perform information gathering using some tools like hardware tools like HackRF or some BLE stripper, and we can try to gather that information as much as possible, and later we can analyze the information so that we can perform further attacks or security testing of IoT ecosystem. Next, one very useful tool is Burshoot Community Edition. This is also free tool, and we can capture all the information from IoT device to server. In between we can capture into proxy server. So we can make some proxy in IoT devices and we can redirect that traffic to Burshoot, and we can see or repeat that traffic. So we can test server as well as IoT device. So how we will test server? Whatever traffic is coming out of IoT device to server, we can change that traffic within the Burshoot. And if we want to test IoT device, so traffic we will allow from IoT device to server to go through, but response we will change. So after changing the response, if malcrafted response is there and IoT device is accepting it, means IoT device is not able to differentiate between proper response from server and mal-informed response from server. So we can use this tool to perform both sides attacks or security scanning. And one good tool is OWASP JAP. Using this we can perform a spider attack or active scanning, so that a lot of payloads will be inserted into IoT devices to test whether it is responding to some set of attacks or not. And this is very much useful tool as per OWASP. And which standards we refer, I will. So one of the major IoT like industry refers to OWASP top 10. So for this IoT top 10 is also there. It is published in 2018. So this provides like top 10 songs of a particular industry or genre. So this provides top 10 risk of IoT security. So simple example, weak guessable or hard coded passwords is one of the top risk in IoT ecosystem. Second is insecure network services, insecure ecosystem interfaces, lack of secure update mechanism, use of insecure or outdated components, insufficient privacy protection, insecure data transfer and storage, lack of device management, insecure default settings, and lack of physical hardening. So all this particular security risk, if you will address, then your IoT ecosystem will be free from at least top 10 risk. Other risk will be there. I will show what all risks are there. Okay, and if anybody wants to practice IoT security related like ethical hacking or security testing, he can start practicing on IoT Code. It is a project from OWASP, and you can perform as per OWASP IoT top 10 a lot of security attacks, so that the student can get familiar with or faculty can get familiar with the IoT top 10 2018. And one of the critical thing is most dangerous weaknesses of software. Actually, vulnerabilities will arise from these weaknesses. So if your products have these weaknesses, that becomes vulnerability in your particular product. So here on this CWE's common weakness enumeration, list of software weaknesses are there. So this is published yesterday, 2023 CWE top 25 most dangerous software weakness, and like this hardware weaknesses are also there. So these IoT devices, they have to address these hardware related weaknesses, and it is around 900 or 1000 weaknesses. In that top 25 or top 10 is only reflected everywhere, but there are so many weaknesses available, and that weakness can affect your product's stability. Okay, so you can see as per your role. Like for example, if suppose you are in hardware design, you can see in this phase what type of weaknesses I can address. Okay, next, if you are purchasing some product, how to identify that product is secure or not secure? So you can go on this website called CVE, Common Weakness Enumeration, and here you can search. For example, I will just search camera. Okay, so here you can search, perform searching. So related to camera, all the weaknesses can be highlighted and you can see. Or if you are finding during your research that particular vulnerability in IoT ecosystem, then you can report a CVE, and this is managed by Department of Homeland Security and CISA. CISA is Cyber Security and Infrastructure Security Agency of US government, and you can provide this vulnerability information to CV and they will report it, and this database is used around the world for vulnerability reporting purposes. Next is one attack framework is there for Mitre. This is used for planning tactics or techniques for various ecosystems. So for mobile ecosystem, this is a attack framework. This is used for red teaming purpose, and here like for example initial access, or for mobile ecosystem initial access, lock screen bypass. So a lot of information will be available for mitigation as well as performing that bypass. Okay, so this attack framework is used by many organizations to simulate the real attack. So you can customize it for your organizational environment. And one very good database is Common Attack Pattern Enumeration and Classification. This database provides list of attacks. Actually, most of the attacks are copying something or other thing which is already available. So this has a repository for complete attack patterns, and you can identify that pattern and try to address that pattern into your ecosystem. For example, for Bluetooth, it will provide like Bluetooth impersonation attacks. Okay, so this thing you can refer, and this is very good repository maintained by Mitre organization. And one of the crucial aspect is API security. Since IoT devices are accessed using APIs, so these APIs needs to be secure enough, and that API security risks are highlighted by OWASP itself, and these 10 IoT API security risks are listed here. For example, broken object level authorization, broken authentication, broken object property level authorization, unrestricted resource consumption. Since many of the IoT device developers are very novice or startups or new into the ecosystem, they don't know its security implication. So better to reflect some of the best practices which is available internationally as well as nationally. And these are the standard I were referring to: reference architecture, guidelines, base requirements, and this is from NIST. And one of the main standard is IoT Security Foundation has recently published, and this has provided a lot of guidance. So for example, they have provided guidance for software bill of material, as well as what is the effect of artificial intelligence, what should be your vulnerability disclosure policy for IoT ecosystem. So all these things are catered into different standard. Only thing you have to follow in your IoT device product designing phase some of these standards so that you can address the security requirement. And for your kind information, as I was telling earlier, that STQC Directorate is operating a IoT system certification scheme. So any IoT device vendor can approach us, and we can certify the IoT devices as per level 1, level 2 or level 3 requirement, and you can use that particular certification to strengthen your IoT product, as well as this is the requirement of many government procurements. For example, railways has a requirement for STQC level 2 certification for IoT cameras. Yeah, thank you, sir. Thank you, everyone. So I have provided my view in this domain, and you can ask your questions.
Yeah, really very wonderful and from your side. We really thankful you for this wonderful session. So in this session, sir, you have covered a lot of things like what are the challenges nowadays we are facing in the world of IoT, like IoT security measures for IoT, and especially for the home securities where we are dealing with a lot of cameras and all that, and we whether not know whether this device is authenticated or whether it is following some certification or like that. So you have with a brief introduction of all these aspects, cover all the several aspects of this presentation. So from the participants, I would like to ask all my participants if they have any questions, they are free to ask. So I request all the participants.
Hello, good afternoon, sir.
Good afternoon.
Yes, sir. One more question is that is IoT is helpful in machine learning?
Yes.
How can we relate the IoT with machine learning? Can you guide, sir?
So one is for IoT security, a lot of signatures you can detect using machine learning techniques. So a lot of attack signature you can monitor using machine learning techniques. So that is one of the prime area. And many other people are, since it requires sensing and a lot of sensor data is captured, so that particular sensor data can be fed into machine learning algorithm, and data can be used for particular purposes. Like for example, one of the requirement is like in Bangalore city, automatic number plate recognition system and automatic traffic challenge system is there. So that is like a IoT camera, and they are using that IoT camera for enforcing traffic rules. So those particular traffic rules, whatever are there, and that particular things are taken care by artificial or machine learning based system. So any IoT device which is sensing and producing a lot of data, you can apply machine learning techniques and you can see this thing. And I have one corpus of this. You can refer to this one. I have captured some of the research papers on IoT security testing. So you can download some of the papers. Approx 167 papers are there on this one, and you can try to get information related to machine learning applications into IoT ecosystem.
Okay, thank you so much, sir. Yeah.
Thank you.
Yes, thank you, sir, for your valuable information. Any other participant? If you are having any questions, please. So, sir, I think all of the participants have satisfied what you have delivered, and it's quite valuable for us also. So, would like to.
What are the
Yes,
excuse me, sir.
yes,
Hello? Yeah, what
yes.
are the advantages of IoT, sir?
So one thing is you can connect any day-to-day object with internet and you can control it. So that is the advantage. You don't have to do a lot of wiring. Okay.
Okay,
So
okay,
means suppose one simple example, suppose water level meter is indicator is there or meter is there for filling of tanks. So that you connect to down completely from your top floor to bottom floor. So if it is IoT, you can configure in such a way that they are talking to each other using some IoT gateways and all, and you can monitor it. So you can save wires and you can remotely monitor things like using IP or IoT camera. You can monitor your home also from anywhere in the world. So that is the advantage.
okay, thank you.
Thank you.
Yes, any other participant? So, as of now, we are having only two questions. So, I think most of our participants are well satisfied, sir. So, thank you, sir, for your valuable time, and thank you to be being a part of this session. Thank you, sir, for delivering this valuable information on all the IT securities and what are the measures that we need to take. For nowadays, network is quite big and quite vulnerable. So I think we have covered a lot of things in this session. So this session could be well knowledgeable and for the participants who just want to be in the field of IoT or very new to this field. So again, sir, we would like to thank you for this session.
Thank you, sir.
So I would like to all the participants to please provide your valuable feedback. Now we are going to end this session for today. So within a minute, we are going to share the feedback link. Please wait.
Sir, your voice is not audible, sir.
So dear participant, today's session is over. So please join tomorrow the same timing. Tomorrow the speaker will be from NIT Jamshedpur, Dr. Mayak Swarkar, on the topic of machine learning. Thank you.